Hello everyone, here is another video on implicit differentiation. It is like the chain rule. What we do is the chain rule here. Remember, if you have to take the chain rule, like you have a function u in terms of x, like y in terms of another variable, and then u in terms of x, then to find out dy dx, we use this chain rule, dy du times du dx. So that's the concept we are going to use here. We are going to differentiate each of these terms with respect to x. So when you are differentiating this y squared in terms of x, d dx of y squared will become d dy of y squared, and then multiply by dy dx. Then the second term here minus, you have two terms, product rule should be used for this one. So u times the derivative of v plus v times the derivative of u. So this will be x squared times d dx of y, which will become here x squared times d dy of y multiplied by dy dx. There's one more term, so let's put the parenthesis over here, plus y times d dx of x squared. So here, look at this. We are differentiating an x term with respect to x. So there's no need of that chain rule. Then you have d dx of 3x cubed equals d dx of the right hand side, which is equal to 4 here. So the same thing we can continue over here also. So let me put parenthesis. So this will be y times, that is this one, derivative of x squared will become 2x, close parenthesis, plus here we are differentiating this 3x cubed with respect to x only. So this will become 9x squared, and then equal to d dx of 4, which is a constant, so the derivative is equal to 0. So I can just put a line over here. Okay, so this will become this part, d dx of y squared will become 2y, because we are differentiating y squared with respect to y. So 2y, but you have this dy dx along with that. So 2y dy dx minus x squared times the derivative of y with respect to y is 1, then dy dx, plus this differentiation is already done, so we can write this as 2xy. Same way, this differentiation 9x squared is equal to 0. So in this implicit differentiation, we are gathering these terms having dy dx together. So before that, 2y dy dx, remove the parentheses, so distribute minus 2xy is plus 9x squared is equal to 0. So there are two terms with respect to y. So what we are going to do is we are going to take dy dx common there. So we are going to write this as, so these two terms, this term and this term. So dy dx common there times 2y minus x squared, and get these terms to the other side. So minus 2xy will become plus 2xy, and then minus 9x squared. Then divide both sides by 2y minus x squared, so that these two terms will be cancelled. So from here we get dy dx is equal to 2xy minus 9x squared divided by 2y minus x squared. So that is the derivative. So look at this. Because of implicit function, we have this derivative also in terms of both x and y. So 2xy minus 9x squared divided by 2y minus x squared. So there's nothing common here. Maybe in the numerator you can take out x as a common factor and rewrite in slightly a different way. X times 2y minus 9x divided by 2y minus x squared. But nothing is cancelling, so it's okay to leave it like this expression also. 2xy minus 9x squared divided by 2y minus x squared. That's the derivative as implicit differentiation. Okay, thank you. Bye-bye.